other. You can see glucokinase. Okay, first step, the glucose trapping. This is actually called glucose trapping reaction. You know, plain glucose without addition of phosphate, it is freely movable into the cell. It will go into cell and again come out of the cell. So this without phosphorylated glucose, it is not retainable. It will go inside cell, it will come out inside cell. So that is why phosphorylation is very important. Once this glucose is phosphorylated, what will happen? This glucose cannot come out of the cell. So that is why this is called glucose trapping reaction, which converts relatively permeable glucose into ionic non-permeable glucose 6-phosphate. And it is a common reaction for 3 pathways. It is not only the step for glycolysis, it is also a step for pentose phosphate pathway. We will talk in MD2. It is also for glycogen synthesis, glycogenesis. So glycogen, both we will study in MD2. So pentose phosphate pathway, glycogen synthesis, and also for glycolysis. So this is the common reaction for these 3 pathways, because it is a glucose trapping reaction. I have already explained, when you eat the food, we have seen the digestion. So glucose will be absorbed through this channel. This channel is called sodium dependent glucose transporter. This is secondary active channel. From intestine, it will be absorbed, it will enter blood, and in blood it will reach tissue through different glucose transporter. And you know, GLUT2 is present in liver and beta cell of pancreas. GLUT4 is present in muscle, GLUT1 in brain. So here in different tissue, glucose will enter and glucose will convert. As soon as it enters, it will convert into glucose phosphate. In liver, it will be converted into glucose 6-phosphate by what? By glucokinase. Elsewhere, it will be done by hexokinase. Glucokinase and hexokinase. And you know, this GLUT2 has low affinity. Remember this. GLUT2 has low affinity, and this glucokinase also have low affinity. You can see this glucose 6-phosphate. Now, once glucose 6-phosphate form, it can join either of this pathway based on the condition of the cell. So it will either form glycogen, or it can undergo glycolysis or pentose phosphate. So as I told you, the 2 types of enzymes. One is hexokinase, other is glucokinase. Glucokinase is also called hexokinase 4. Here, these 2 points are very important. Glucokinase has low affinity. Remember, glucokinase has low affinity. What does it mean? Glucokinase has low affinity means when your liver, glucokinase is present in liver, and this glucokinase characterizes liver. So when glucose is low during fasting condition, your liver is very, very kind tissue, very, very generous tissue. When you are in fasting condition, you are not having anything. So what does actually you have to understand between the liver, the relation between the liver and your brain. So actually liver lives for brain. Actually liver is always helping brain. When glucose concentration is very low, liver does not touch glucose. It is spare glucose for your brain. Okay. When you are fed, when you are fed, what will happen? There is very high amount of glucose in your body. Okay? Sufficient glucose is there in your body, available for all tissue, for brain as well as for your liver. So what does this glucokinase do? Glucokinase has low affinity. Low affinity means now when glucose is very high, then only this glucokinase will take up this glucose. When glucokinase is in very sufficient quantity, and then what does this liver does? This liver stores glucose for bad condition, for bad situation, for rainy days. So this is mother. This is present in liver, and liver is mother, or you can call it liver, you can call it mother. And this brain is baby. So baby has very high affinity for chocolate, more than mother does, or food. So what does mother do? Brain is baby. So what does mother do? When glucose is low, mother because mother has low affinity for glucose, mother will spare for this brain, will not touch that glucose. Let it be for brain will utilize it. But when it is very high, then only this liver will utilize. Because of this glucokinase affinity, the whole scenario will change. The liver become mother and this become like baby. So you memorize one thing, and you also memorize this glucokinase is under regulation of, very tightly regulation of insulin, not hexokinase. These two important points are very important, and you will you will memorize this all. Then just remember these two important. Glucokinase has low affinity, and affinity is opposite to this Km value. This is opposite. Affinity is opposite of Km. So you will remember. So those which have high affinity will have low Km, low affinity will have high Km. So let's see. So graph is also like this. So this is sigmoid shaped graph. You will see initially when you increase glucose concentration, the enzyme, this glucokinase will not touch. No problem. There will not be increase in activity. After certain point, after optimum glucose level is reached in blood, then there will be sudden jump. Then it will start utilizing glucose. What does it mean? When you get rich, when the mother get rich, then mother start utilizing glucose, and that glucose also will be mainly, some glucose will be utilized, some food will be utilized by mother, but more of the food will be stored in the form of glycogen. So this is the power, this is the mechanism why nature has made different enzyme in different tissue. The same enzyme, isoenzyme, these are two isoenzymes, the different isoenzymes with different activity in different tissue. So you can see the significance of glucokinase in liver, and that is why glucokinase follow this curve, and then hexokinase, sudden little bit glucose concentration. So glucose will, this enzyme hexokinase will convert glucose into glucose 6-phosphate. Sudden rise. This is called high affinity. This is low affinity. And affinity jump is there. After a certain point, there will be affinity jump. So there will jump, and then it will start utilizing